Hi, this is Tim, and welcome to Talks with Tim, and we are bringing this one live on YouTube. And I went live yesterday to do a RsLogix to Connected Components Workbench conversion, and I had quite an experience. It didn't work, and I didn't have my wingman with me. If y'all don't know it, the guy in the background here, who's actually doing schoolwork right now, so he needs to turn back around. He is a big supporter of helping me keep all this video stuff going, and he's been live streaming and had showed me everything, but he wasn't here yesterday and I botched it. And so then, just like when we have a machine that isn't working, I hit every single button on it, and I ended up getting 2 live streams going. And yeah, invited to a lot of live stream type events. You know, people want me to be guest, and I'm like, I can't do it. So this is another practice at that too. But I wanted to hit some of these questions because they were really good. So first, Kevin Burt in the chat had asked, do you need RsLogix 500 or RsLogix 5000 for this? And this is probably one of the most difficult things in any, well, really it's not even in any PLC, in anything that is software related to navigate, is figuring out what software you actually need. So if we pop over here to our screen, then first, this is our Connected Components Workbench. This is the program that we were working on. And if I click New, this is really the easiest way to kind of view what all you can use these for. Whoops, I need to save that. The save. All right, if we go into the Connected Components Workbench, you can work with a large variety of systems with it, but mainly controllers are going to be our PLCs. And for the Connected Components Workbench, it's going to be anything that's a Micro 800. Now, don't confuse the Micro 800 with the Micrologix PLC, because they are 2 completely different animals. So the Micro 810s, Micro 820s, Micro 830s, Micro 850s, and Micro 870s are the PLCs that you would use Connected Components Workbench for. Now, if we pop over to RsLogix 500, which is what our program was in that we were converting, and we click the new on it, probably should have had the new already clicked for a live stream, but we wait here. Might as well go over to RsLogix and do it while we're at it. Oh, no, it came up pretty fast, but all right. Oh, I'm in View. Logix. So for it, you can for Studio 5000, which is formerly RsLogix 5000, you can program the CompactLogix and ControlLogix PLCs. And also that includes some of them like the GuardLogix and various ones. But really, the best thing to do is just open them up and browse through what you can open with them. But yeah, this will be all the CompactLogix. And then if we go back over here, oops. Oh, well, let's just hit new there. Then for the RsLogix 500 software, it's going to be all your Slick 500 PLCs, which are kind of usually shorthanded as like a 505, a 504, a 503, 502, and the Micrologix PLCs, which is going to be the 1000s, the 1100s, the 1200s, the 1400s, and 1500s. And again, it's a little confusing because we have Micrologix, which is programmed with RsLogix 500, and then we have the Micro 800, which is programmed with Connected Components Workbench. So hopefully that kind of clears that up a little bit. All right, next we had Industrial Concepts, who is Mark, that we actually did a collaboration with the conveyor trainer. He asked for clarification about, in our analog scaling, shouldn't it be 2100? So let's pop back over to that program. Let's see, let's cancel this out. And if we go into the calculations here, then what I did here was I had our value, our analog value, minus 4,000 for that 4 milliamp offset. And then I'm multiplying it, then I'm dividing by actually 16,000 or 16 milliamps. And he asked, shouldn't this number be 21? Well, no, it should be 20 or 20,000, because this value right here that we're getting on this analog signal, when we scale it, it's going to be 0 to 14 for the pH or 0 to 5 for the level. And so we want our scaling to be from 4 to 20 milliamps, 0 to 5 or 0 to 14. So if we just plug some numbers in here, let's just say, well, let's start with 20 milliamps, because that is, you know, our maximum scale. So at 20 milliamps, this is going to give us 20,000 right here. So we're going to do 20,000 minus the 4,000 where we have that live 0 on our milliamp signal, and that's going to give us 16,000. And then we're going to divide it by 20,000 minus 4,000, which is also 16,000. So divided by 16,000, it's going to equal 1. And so 1 times whatever our maximum number is going to be our maximum number. So that is going to give us 4 to 20 milliamps equaling 0 to 5 or 0 to 14. So now we can still get 21 milliamps here, because I probably should do a video talking about that. You know, the range of this is 3.2 milliamps to 21 milliamps. And there's an important reason for it. Is first, if we have a broken wire, we're going to have less than 4 milliamps. And that's going to tell us, you know, having that 3.2 is going to tell us that, whether we're just marginally low or we're wide open. But also a lot of times you will signal a fault on your transmitter with 21 milliamps. So we give a normal signal, and then if whatever's connected to it, such as a pH probe or whatever, is bad, then we'd actually send 21 milliamps to say, hey, my milliamp signal is fine, my circuit is fine, but whatever's connected to me is not working. So let's say we did get a bad pH transmitter. It's going to put 21 milliamps out. Well, that's going to be 21,000 right here on this number. So now we do 21,000, oops, and we're going to still subtract the 4,000 for our live 0. And then we're going to divide that by 16,000. And this is going to give us a value that's slightly above what we have. Now if we multiply that by 20, because that's our high range of our value, we'll end up right back at, actually let's do it, times 20. Oops, I did a math error somewhere, but that should be 21. I don't know where I typed wrong, but somewhere in there I did. But anyway, no, this value right here is not the full range of your analog, which let's refresh on that. We go back, let me see if I can find that screen from yesterday. Yeah, if we bring this in here, this was, let's see, I'm on page 8. And scroll up. This is our Micro 800 expansion I/O modules. Then yeah, our full range is 3,200 to 21,000. But that's not the 4 to 20 milliamp range. And I think that may have been where the confusion was coming in. Is if we look down, see here we have a note 4. And if we look down at note 4 here, then 4 to 20 milliamps, the range of it is 3.2 to 21 milliamps. So yeah, when we want to scale our full scale of 0 to 14 or 0 to 5, we don't use the 3,200 to 2,100. We would use 4,000 to 20,000. Okay, so next, all right, I have one that I am working with a Micrologix simulator and it keeps freezing. Well, you know, here's where, and this isn't really the perfect answer you want, but part of the reason I'm doing this conversion is that the RsLogix 500 and the Micrologix, and including the simulator, are not supported anymore. And really, I've never particularly liked that simulator, but it definitely was quirky. Now, I've played a little bit in Connected Components Workbench with its simulator. See, right here we have a Micro 800 simulator, And if I click it, then we can get a PLC here. I can turn the power on to it. And yeah, we can simulate inputs and everything. And if I had a program running, it would spit outputs. And the times I have found a few things that are not the same in it compared to a real PLC. But as far as, we'll say, real basics, just trying to get a handle around mainly whether you really want to enter the PLC program in field, this seems to work okay. Now, as absolutely soon as possible, you need to get some real hardware. But I would say overall, I do like this simulator better. All right, and here's why I really needed the chat is I was struggling in our sequence program, and I did figure it out, but and I'm gonna butcher this guy's name, Dudu Por Q, and I'm sorry, I'm sure I got your name really wrong there. But he shouted it out right away when I'm watching the stream that I was trying to make this tag right here sequence. Well, I don't have any other tags named sequence, but you can't have anything named sequence. So since I had named this routine here as sequence, I couldn't name that as sequence. So yeah. So duplicate tags, it also encompasses everything over here, and I would guess it encompasses add-on instructions too. But he also said, I'm impressed with how calm and patient you are working with the CCW and RsLogix 500 conversion tool. Well, I don't want it to come across that this is not a good effort on Rockwell's part. And what he's talking about is we have the Micrologix to 800 converter, and it will give you a rough structure of what you're wanting to convert. But just like when I went through that program yesterday, we found a lot of places that really, maybe what I did, I could have done better. And so it gave me that second view. But also, they have no way of anticipating that you would name F80 tank 1 level as a tag. So there is a difficulty there. And so it still works well. I mean, we ran it. We did have some errors. We were going to have some massaging to do. But I can't think of a single instance that I personally would use this, except if we had a machine down, and honestly, this would probably be 20 years down the road. But let's say I had a Micrologix 1400 down and I could not find one. And I'm in a pinch that I would do the conversion, throw something together, and manage to get the machine back up and running. But even then, I think I would go back and start writing it pretty fast on that. But it is a useful tool for some people. And, if you're looking for an automatic conversion, then yeah, it probably is as good as any other out there. Okay. All right, I had a question. Will these live streams be available later? Well, as long as I don't totally bomb on one of them or I don't freeze, then yeah, they probably will be. We're going to play it by ear. Like I said, the live streams are really intimidating to me. I know that surprises a lot of people, but like I said, I'm definitely not camera. I am severely camera shy, and I'm not one to get up on a stage, so it probably goes along the same way, but I will try to make sure that they are still available. All right, next we had, Tim, can you do a video on Logic logo for Siemens? Probably not. And here again, just like I talked in the last podcast, is you need to find what really works for you, or find that one thing and stick with it. And I can program Siemens, but I wouldn't call myself anywhere near the top of the Siemens game. And so I don't want to put out information where, it isn't maybe the best. I mean, it's the best as far as I think, but I don't work with Siemens enough really in the field. I don't run into Siemens in the field. And so in this particular area, it's hard for me to get the experience to really showcase Siemens. Now we're in that sentence that I say that Siemens was not a good PLC. They're an excellent PLC. They're an excellent automation company. But it's just not something I get a lot of exposure to. All right, next we had one from Lucas. This one actually came in as an inquiry, and it actually fit really well with this, so I'm going to do it. Lucas is trying to scale a magnetic pickup for a turbine flow meter. And it has 2 wires, and it sends a pulse instead of a 4 to 20. And he's read in the manual, it's a 0 to 5 volt signal, and he wants to connect it to a Micro850 PLC. And while he can read the input, he can read 5 volt, they can't get it to pick up the magnetic field. So there's a couple things going on here. First, the Micro850, for those who don't know, its first 4 inputs are actually, let's see here. Man, it'd be great if I had one here, but I don't. Okay. Well, let me see if I can throw one up here real quick. Actually, probably it doesn't matter. We'll just, so yeah, the Micro850, if the first 4 inputs on it are actually discrete inputs plus 0 to 10 volt DC inputs. So you can read an analog signal with those. And so what Lucas has done is he's managed to connect 5 volt to it, and yeah, you can go into the PLC and you can read it. In fact, yeah, let's create a Micro850 PLC real quick so we can see where we could do that. If we go into our controller variables, then typically we're looking at these IO, EM, DOs right here, or mainly DIs. There's your digital inputs. But right below it, if you've got that Micro850 selected, we actually have 4 analog inputs also. And these are the same physical terminals, this DI00 and this AI00. So you can read them either way. But the issue is what Lucas is wanting to do is he wants to get a pulsed input. And you cannot feed a pulse to an analog input because analog inputs typically have some filtering on them because analog is a little more susceptible to noise. So you'll try to filter that noise out. But when you have a pulse, chances are it's only on for a few milliseconds. So in that case, you actually need a high-speed counter card. And that would be this 2080 MOT-HSC, the Micro800 high-speed counter plug-in. And we have some videos on how to configure this. Actually, we have it on configuring the Micro850, but this would be the same. But yeah, if we go down here, well, they mainly show it connecting an encoder to it, but you can connect a single pulsed input to any of these. And so, actually, yeah, there you go. So there's how you could connect yours, but you're going to need this plug-in module for it. And we have, actually, let me just, yeah, because I could paste this in the chat. If I go to twcontrols.com, we have a video on this, lessons, the Micro800. I guess I could put this over here, you could see what I'm doing. Well, yeah, so twcontrols.com and then go to lessons and Micro800. And then just search for high speed, and we have several of them, but right there is high speed counter configuration for encoders. So this is going to tell you how to configure that plug-in module once you have it, so I'll paste it in the chat. And then, yeah, but if we look down here, the only thing I was thinking while I'm sitting here saying this is, okay, yeah, so the input voltage range 0 to 30, got that, but our on state voltage range is 2.6 to 30 volt. So it should work with a 5 volt input. Now I've only used it with 24, but I'm pretty sure you'd be good with 5. So hopefully that'll help you out there. But okay, I just wanted to pop on and answer those questions because especially since that was the whole point, was that I was supposed to be able to answer questions during it. It was just embarrassing that I had answered 0 questions. So I hope this video has been helpful, and let me know if you think that we should continue the live chats or whether we should stick to our day jobs. Got Amber here beside me laughing about that. But that's all I got for today. Till next time. Hey, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!